my channel. My name is Daryl and this is Programming in Any Language. We are currently working in C#, but everything we do here can be done in Java, Python, and virtually any programming language, as you'll soon discover. Today we are looking at preventing data conversion exceptions. What does that mean? Well, we generally write programs for other people to use. Sometimes those people, which we'll call users, enter things we didn't expect. Sometimes, actually quite often. Preventing data conversion exception means getting ahead of the users, predicting they will do something we didn't expect. We'll get one step in front of the users and bulletproof our code so it continues to work. Here, I'll show you what I mean. A lot of our programs are written with the programmer in mind, not necessarily the user in mind. And those kinds of programs, we can take data like the loan qualifier right here and pop in some numbers. We know we're going to be able to put an annual salary in and a year's of the current job. But what if the user goes and does this? Puts in 40,000 and puts in, let's see, 3 years on the job. And then we go and check qualifications. What's going to happen is we're going to get a salary error. At least we'd like to get a salary error. Up to now, we wouldn't necessarily do that. But being able to fix this is something we need to do. So we can actually high-low over this thing right now and type in something different, like, let's say 40,000. We need to actually clear it, put in 40,000. And we still make the mistake of putting in 3 years and check the qualifications, and we get this particular error. And once again, we screw that up, so we want to put in a 3 and fix that up. And now we can go ahead and do our qualification check and get it properly set up. This is preventing data conversion exceptions, is really what we're talking about here. We have text boxes here. We're trying to bring in numbers, and while we as programmers know that numbers are supposed to go in there, our users don't necessarily know that. So getting that to work is something that we're going to be talking about now. Preventing data conversion exceptions. That's really what we're talking about here. Exceptions should be prevented whenever possible. The TryParse method can prevent exceptions caused by users entering invalid data. That's what we're going to be using. Up to now, we've been using try-catch, which catches any error, all kinds of different errors, and which is good. But it's nice to be able to specify and tell the user just what they got wrong, so we can identify it. And the TryParse method goes in and looks at the data in the text box or wherever it's coming from, and tries to parse it right there and into the data type we're looking at, like an integer, a double, a decimal, whatever. So int TryParse, double TryParse, decimal TryParse. And the generic syntax is int TryParse. You put the string in, which is going to be your text box or whatever. You say out, and then you create the target variable that you're going to put it into. So the target variable is there. You're naming it here. The out keyword is required. It specifies that the target variable is an output variable. So that's really what we're talking about here. This is the kind of format we'd have for int, integer, double, and decimal. Basically, with a little comment up here, we have an int number coming in. So we created an integer number, and then we use an if statement to do this. If, and we TryParse the text box we're coming in, and if it's successful, it's going to go into the number, this variable we actually put in here. Same thing with the double TryParse. We set up a double variable, and we TryParse that input text box and put it out to a number double if it's successful again. If. So there's going to be an else in these things. So if something goes wrong, we're going to have an error message come up. And if we have decimal, same thing. We do the same thing right here and pop that in. So when we run it, and as you just saw in the example a few minutes ago, this guy right here, if I typed in garbage and more garbage and try to check qualifications, instead of it trying to parse that, it hits the else statement on this, and we end up with the error coming up on the specific value we're looking at. So it's checking this guy first and causing us to stop right then and there. We fix this, and we go on to check the qualifications again. We now have the error over here because we did not fix this thing at all. So we need to click fix all those things. That's really what we're talking about here. So this is basically prevention of data conversion exceptions. So we've got the theory down. If you have an idea, by using an if statement, we can create 2 paths. One path will be normal processing if the data coming from the user is proper, the true path. Another path, the false path, which will point out the error to the user in an elegant fashion so they can correct the error and the program doesn't blow up. That's what we want. How do we do that? let's check out this video. Okay, we've all seen this before, the loan qualifier program. Just to refresh our memories, I'll run it real quickly here and we'll take a quick peek at what it does. It allows you to enter a salary of maybe $40,000 and maybe a current use of the job of 4, and it determines whether or not you're within the range of 40,000 if you're making above 40,000, and that your current been at the job more than 2 years. And if so, it'll qualify you for a loan. If it's less than that, of course, it is going to be let's make it a 1. It's going to say, no, not qualify, years of the job too short, something of that nature. So this program is not totally complete, and I'll show you why. Clear doesn't work, so we'll fix that up real quickly, and I'll just blow these things away. And let's go ahead and add, let's see, $40,000 again, and 2 years on the job by saying 2, and then hit check qualifications, and bang, she blows up sky high. We get an unaccepted error. Yeah, of course we get an error. We haven't checked for anything. This program simply is written to run and to show us what it can do, but we need to bulletproof this thing a little bit, and part of that is going to be making the thing proofed in such a way that the user can't enter bad data, basically. So let's go ahead and see what we can do about this thing. So let's kill it. Go ahead and debug this thing, turn it off. Stop debugging. There we go. And let's get into the code. There's our code right here. We can see it right here. Though it's not a lot of code. That's one thing I like about this program. We can kind of play with this thing and realize that we don't have that much to deal with. But we do have a problem here. We don't have anything to cover what's going wrong when something happens here. We are looking at the decision, and that's working just fine. But the salary is coming in. We're parsing it into a salary. We're looking for 2 doubles to come in here, but we're not doing anything to fix that. Okay, let's go ahead and fix this program by giving it a try catch statement that's going to catch the errors that are sitting in this thing. So what I'm going to do basically is this whole block of code is something I want to sit into. I want to check before I actually do anything else, and if it works fine, great. I don't have to change it. But if it doesn't work right, I'd like to tell the user that something's wrong. So I'm going to put an entry here, and I'm going to put an entry here. And right in here, I'm going to put in a try. I'm going to say TRY and put in a set of braces. And there they are. The braces are sitting there. I can actually go like this, and then it creates my try block. And I'm going to sit in here and hit enter, and I'm going to say catch, C-A-T-C-H, and put in my set of braces here. And it creates a block like this. So now I've got my try. If something goes good in here, it's going to be fine. If something goes wrong in this area up here, then I want it to drop down to the catch area and give me a message. So I'm going to take all this code I just pulled out, and I'm going to do a Control X on it to cut it, and I'm going to move it to this area right in here. So now what's happening is this set of code is going to be checked. It's going to be tried. And if it fails for some reason, it's going to drop us down to this catch block right down here. So down here, I'm going to put in a message box. Message box dot show, and I'm going to say something went wrong. Not being very specific, but I'm sticking something in there that's going to show us that. So there's our code right now. So we've got the try in here. Everything's the same as it had been before we actually did our processing. And now we're going to actually go down here and see what happens. I'm going to save this file, save as, save all, and then run it. And the program should come up. It does. And we see a loan qualifier, and we can type in the 40,000 again, and the 4, and works fine. You qualify for the loan. That looks good. Change this to a 1, and you don't qualify. Your years in the job is too short. Now let's type in the 2 here, just the TWO, and see what happens. Check the qualification. Something went wrong comes up here. Oh, what's going on here? So what you can do is the user now can click OK and look and try to figure out what went wrong. You might have said that invalid data or something of that nature, but now the user can go up there and say, oh, it's going to be 3, pop and check, and it works just fine. So if you look at the code now, this try catch, the try identifies that something was wrong here and tells the user something went wrong and lets the user go and figure out what happened. That's good. It works fine. But there's a better way to do this kind of thing, and that's the TryParse method. We can actually look at individual elements. We can look at the salary and the years and inquire which one's wrong, and if one is wrong, we can tell the user that particular one is wrong. We're not quite there yet. What we saw was the implementation of the try-catch method, which catches any error. The downside is that it doesn't tell us what the error is. It just tells us there's an error. In a small program, that's probably not a problem. But if you're entering data from, say, a hospital admissions form, you'll find that there's a ton of data on a form like that. If we spend 10 minutes entering all that data on a form like that, and we get a message that something's wrong, that really doesn't help us very much. We want to know specifically what is wrong. It'd be much nicer to identify each and every error so the user can quickly fix it. Here's what you do. Okay, here's that same program we used just a little while ago. The try catch has been pulled out of it. We're back to the normal way we actually started the thing. It runs as we saw before, but the 40 and the 40,000 and the 4, that'll do fine. This time we want to look at each individual piece here. That means what we want to do is we want to actually do a try catch on each, or a try parse on each one of these things. So looking at that format, I'm going to go ahead and leave this as read data from the user, but I'm going to give myself some space here just to kind of make this work. Okay, what we're going to do here is we're going to basically create an if statement. We're going to say if, and since we're bringing in a double, we want to say double dot TryParse, double dot TryParse, and then we're going to say the text box we're looking at, which happens to be txt salary first, I think salary dot text, comma, out DBL salary. So what we're doing here is we're looking at the text box, text salary right here, which we would have done before in the try right, or actually in the reading here right here. But instead we're going to be doing an if statement here. So we're going to look and we're going to try to parse this thing. And if there's a problem, we're going to create a block of code. Well, actually, this is where it's going to be good. If something's good here, if it actually does parse it, it's going to be fine. That means we're going to have an else down here. And that else is going to be going to have its own block. And in here is where we're going to put the message box in. And we're going to say salary not valid. And that's fine. That works. So if the salary is correct, we're fine, and we can do something else, do something that's good. Well, the next thing we want to do is we want to bring in the years. So we're going to put another if in here. Be a nested if. If double dot txt, now double dot TryParse, txt years dot text, comma out DBL years, DBL, I got to spell it right. And this too is going to have its own if statement. I got to spell it wrong, DBL years, there we go. Now it's correct, and pop it down. So it has its own if statement. So if this is correct, we can go ahead and process. Otherwise, we have another else down here. So we'll just put in an else, and put in the block, and message box dot show, and we can say invalid years entered. So what we've done is basically we've checked, we've done these two lines of code right here, but we put them in if statements. So we're checking if this is correct, go ahead. If this is correct, go ahead. That means in here we can put the code that actually does this work. And that's the make decision stuff. So this part right here, we can take it and put it right inside this if statement. And now what's happened is we should be fine. We don't need this anymore though, because we've done the read up there. So we can just basically blow this away and get rid of it. So what we've got now is our try catch. So let's take a look and see how this thing runs. I'm going to do a file, save on it, save all. And then I'm going to start it. And we'll give this thing a shot. The program comes up. We'll enter our 40,000 once again, and our 4 or 5, and check qualifications, and we qualify for the loan. Does the 1 pop up? Oops, 1 actually left it like that. Not qualified, too short. That's fine. And we're going to put in the word 2 in here and do the check qualifications. It comes up and says invalid years entered. Oh, I made a mistake. Okay. Let's make that a 2. Let's screw this up. Let's put a $sign in front of this thing and see if that works. Salary not valid because we had to put a $sign in. We can't do that. This is a string coming in. We can't convert that. So we now know that our salary is not valid. So it's actually telling us which particular line of code is wrong. And so it's allowing us to correct the error we've got in. So this is going to save the user a ton of time and trouble when we go through this kind of thing. If we leave them both garbage and run it. Salary not valid. Oh, better fix that. So it does it one at a time. Check qualifications. Yep. Years not entered. Okay, got to do that. 3. Finally, we qualify for loan. Everything is fine on this thing. That's how this thing works. So let's take a look at it once. How it actually runs. We're going to end it. We're going to put a breakpoint in here. Right there's fine. And we'll run the program. What we're going to do now is we're going to actually run this thing by putting in, let's put in garbage in each case here and just see what happens. We'll check the qualifications, and the program right away stops at the if statement. And we look at the salary and see what's coming in, and we have 0 in there right now. So we're going to actually process it by pressing F11. We'll press F11. It drops down in the message box where salary not valid. Oh, it didn't like what it saw, so it gave us this message right here. We go ahead and it gives us that message. We can fix that. We now can go ahead and do another F11, step through this, and we can now fix the salary. Okay, we'll make that 40,000 and do a check qualifications on it. Run it again. This time it's up there in the top. Hit F11. It likes this. Drops down to the next line, and we now have our salary is 40,000. We could actually do a watch on this if we wanted to, but you can see it came in. It did get that salary. Now we're going to bring in the years, and we press F11 on this thing to get it to execute. It drops down to here, invalid years entered. It just drops down to that code, shoots the message out there. We're allowed to do something about it. Go ahead and finish the processing. It drops down. And we can fix this to our 4. Go ahead and check qualifications again. And this time, we end up right up on top again. We go ahead and check the salary. We get it. We get our 40,000. Look at our years. Nothing's there yet, so we press enter and process it. And we've got 4 coming in there. Now it's going to make a decision. If the salary is greater than or equal to 40,000, and is it? Well, it was. So is the years greater than 2? Yes, it is. So it drops down here. It goes ahead and you qualify for loan. And then it drops out, skips these else statements, and drops down to actually run our program and bring up our form and go with it. So the debugger helps a lot when you're actually looking at this kind of thing, because it allows you to look at each line of code and how it's actually processing. You can follow it through on what's actually going on there. The difficult part is basically, let me get rid of the breakpoint here. The difficult part is being careful when you structure this thing. That's why the indenting is so good, because you can kind of see that these braces match up The if double here belongs to this, so this else right down here belongs to that one going wrong. And this one here has its own else. And if something goes wrong here, you'll see it come up here. Otherwise, if everything's good, and it can go down here and do this. So that's basically how you do a TryParse. And you can identify each piece of data that might be wrong. Much better. The TryParse gives you, the programmer, the power to identify individual errors and take steps to correct them. You may have noticed that when the if statements were created, the false paths were always completed first. This was done for a reason. They are short and easy to complete. Get that out of the way. In addition, you want to keep the focus on completing all the negative paths first, so you end up with the exact spot where the processing should begin when the data all passes muster. You don't have to do it this way, but I find it helps prevent logic errors and shortens my testing time. It's kind of something I wasn't taught. I just kind of learned it over time. Next time we'll look at reasonableness of data. Reasonableness. In other words, the user may be entering an integer where we expect an integer, but should our program let the user type in a quantity of 7 million for a paint job estimating program? Probably not. Think about that. What you need to take out of this video is the try-catch catches any error nicely but doesn't tell you what that error is. The TryParse specifies exactly what the error is. This wasn't said, but you can use both in the same program. See you next time. Thanks for watching. If you get a chance, please subscribe. We'll see you in the next video. Take care.